What do we do today?
I think let's talk about trigonometric identities, trig
Sure.
identities.
Sure.
There's going to be three
Uh-huh.
that will derive, and I guess the nice thing about these derivations are that you'll have these memorized. The viewer, have these memorized for use for integration or for tests and things.
Uh-huh.
But if you know that it's derivation, then if you forget one, then you can quickly make it out
Sure.
of the things that you already know.
Sure. So with the trig function, we have 6 of them, but the main ones are sine and cosine, right? And we know the other trig functions using sine and cosine. So it would be natural to think that if we know the trig identities involving sine and cosine, we should be able to get the other ones from it.
Right. Yeah. And let's start with talking about sine and cosine,
Sure.
or cosine and sine.
Sure.
We had previously defined them as if we have a unit circle, a
Uh-huh.
circle of radius 1,
Uh-huh.
and you have any angle on that unit circle,
Uh-huh.
the x-coordinate we called the cosine of that angle,
Sure.
and the y-coordinate we called the sine of that angle.
Yeah.
So those are how we defined what cosine and what sine meant.
Yes.
And also that unit circle, that circle with radius 1, unit, like 1 unit is the radius.
Yeah. Yeah.
We also have an equation for that.
Which-
X squared plus y squared equals 1.
1.
Now that's the equation of a circle. You might just start with that because you
Sure.
know the equation of the circle.
Yeah.
Or you could start with Pythagorean theorem, and any triangle you would make on the circle
Yep.
would have, because it's unit circle,
Yeah.
would have a hypotenuse of 1.
One.
One side would be the x,
Yeah.
the other side would be y. So
Y.
x squared plus y squared equals
Equals
1
one.
squared would
Yep.
just be Pythagorean theorem.
Yeah. Exactly. Yeah. Yeah.
And
So-
that's,
yeah.
sorry,
No.
some people call these three identities that we're going to make the Pythagorean trigonometric identities because of that.
Makes sense. Makes sense. And but x squared plus y squared equals 1. It's a standard equation for a unit circle centered at the origin. So we can start there. And as you mentioned, we said the y coordinate is sine theta and the x coordinate is cosine theta. That's how we defined it before.
Right, so if I take this unit circle,
Mm-hmm.
not do that, and like you're saying the x we said was cosine.
Cosine.
So I'm just going to replace the x with the cosine.
Uh-huh.
Oh, okay. Other thing, the notation of that cos
Oh, yes.
squared, that we write it like that,
Yes.
even though we mean the cosine
Whole
is
squared,
squared.
yeah.
It's just
a
the
notation.
way the notation
Yeah.
works. I'm going to do the same thing with the sine
Sure.
and the y. I'm going to do that because it's a square. Okay, so this looks too easy, right?
Yeah. Yeah. So now we have our first identity, right? Cosine squared plus cosine squared theta plus sine squared theta equals 1.
That's our first Pythagorean trigonometric identity.
Exactly.
Some people call that the grandfather Pythagorean trigonometric identity.
Okay. I
Or the
don't think I
main-
heard that. I heard that term before.
Oh, okay, maybe it's just me that calls it that then. It's because I think of it as we're going to make the other two
Oh, I
out
see.
of this one.
Oh, makes sense. Makes sense.
Okay.
All right, so how do we get there? So let's start with the cosine square theta plus sine square theta equals 1.
Okay, so I'm gonna put this down here because we're gonna do the same sort of modification of
Yeah.
that, right?
Yeah. Well, we could, so we know what well, that would work. What if we divide, because we can divide both sides by the same function, right? So what if we divide both sides by cosine square theta, because we have a cosine square theta on the left side there.
Right, so I'm gonna, just so that, I'm gonna do it this way.
Sure.
Just, so we're dividing everything by cos squared.
Yes.
So I'm just typing this down to like, so that I have typed down what you said. So it's like divide both sides of the equation by cos squared. It's
Exactly.
Okay. Except this will be cos squared divided by cos squared.
Yes.
Oh, wait. This is going to be a thing, right? If I can't just cancel these cos squares, right?
No.
Like
The way I think about this, the cosine square and the denominator applies to both of those both parts in the numerator.
Across this plus sign.
Yes, across the plus sign, exactly. We can split them though.
Let's do that.
Yeah.
So I'm going to split them at that plus sign.
Sure.
So that'll be cos squared divided by cos squared plus.
Yeah.
It'll be, I guess, the sine squared divided by cos squared.
Yes.
That'll be sine. Okay. And I still have this 1 over cos squared here.
Yep.
Okay, cool. Looking over here,
Yeah.
secant is 1 over cosine.
Cosine.
So I can make this whole thing.
So I think the reason that being is the 1 over cosine square theta is cosine theta the whole square, right?
Yeah.
So 1 over cosine square theta is 1 over cosine theta the whole square. So using that identity in that formula, that becomes secant square theta.
Right. I'm trying to make it that it's clear that the secant is, that the angle theta is inside the secant.
Yes.
Okay, so all we did was replace that with
With
our
secant square
secant.
theta. And the left side, right? So cosine square theta by cosine square theta, that becomes 1. Sine square theta by cosine square theta. So same idea, right? That is sine theta divided by cos theta the whole square.
Right, so I'm gonna type what you're saying, but I'm gonna do it this way on the tan here.
Sure. Yeah, exactly. So that second term in that equation there, sine square theta divided by cosine square theta, that becomes tan square theta.
Okay, and let's clear that out of here.
Ha.
That's our next
Second one. Or
second identity,
Oh,
second trig identity.
And I don't know about you, but I always get confused. Is it 1 minus tan square or 1 plus tan square, right? So I always go this route. Like I know sine square theta plus cosine square theta is 1.
Yeah.
And I always divide by the appropriate trig function to get the next one. Because I couldn't remember whether it's 1 plus tan square or 1 minus tan square.
Right, so if you're not sure, it takes 2 seconds to just make it. Yeah.
Exactly.
So I'm gonna, this one's good.
Yeah.
I'm gonna put it up here underneath this underneath that. So
Yeah.
we started out with that unit circle.
Yeah.
I'm gonna just get rid of that.
Sure.
And I'm gonna try and keep a list of these identities. So
Yeah.
we started out with the one I call grandfather.
No, that's a
and
good
then
name. Yeah.
We made this one.
Yeah.
Okay. So let's start with that same one again.
Yeah.
But instead of dividing by cos squared,
It's the
let's
sine
just divide
squared.
everything by sine squared.
Yep.
Yeah. Okay.
Same
so,
idea, right?
Right. But now I've got
Cosine square.
cos.
Yeah. Cosine square divided by sine square, which would be tangent square. Sorry.
Cotan, right?
Cotangent, my bad.
Which is just like the reciprocal of tan.
Yeah.
And then sine squared divided by sine squared is the 1.
1.
Okay, so I'm again dividing the cos. It's like undoing common denominator, I
Yeah,
guess.
exactly.
And instead of 1 over secant, this will be
square.
cosecant.
Cosecant, because 1 over cosine square is cosecant. So we have
And
the next one.
that's the next one. Okay. So, as promised, here are the three Pythagorean trigonometric identities.
Exactly. And the good thing about this is the derivation is really quick. And I don't have to worry about, do I remember the plus and minus at the appropriate places, right? Because sometimes we write this as tangent squared theta minus secant squared theta equals 1, but that's just rearranging those terms there.
Yes, yeah.
But if I start from sine squared theta plus cosine squared theta equals 1, I don't have to worry about do I have a negative sign somewhere or not, because it's just the derivation. It takes one step.
Right, and the these three formula here, these three trig identities, they help me memorize my trig derivatives.
Ah,
Right, because sine and cos are connected
Sure.
in their derivative.
Yes.
So if one changes, the other has to change.
yeah.
So they show up in each other's derivatives. The derivative of sine is cosine. The derivative of cosine minus sine. They're connected.
Yeah.
Tan and secant are connected. The derivative of secant is Sectan.
Yeah.
and the derivative of tan is sec
Secant
squared.
squared, yeah.
So they show up in each other's derivatives
No, that's a good point.
because they're connected in
Yeah.
these formula.
Yeah.
Likewise for cotan and cosecant.
Yes,
So it
exactly.
helps me remember. It helps me remember
sure.
that.
That's a good point. Yeah.
And the integrations too, right?
Yeah,
The
sure.
integral of so here's one that's hard to remember for the integration. But if I'm integrating secant, okay, never mind what it is, but I know it's got to have seeks and tans
Tans
in
in
it.
it,
They're
yep.
connected. It
Yeah.
helps focus down what my
Yeah, no, that's a very good point.
how
That's
to
a very good
remember
point.
things.
Yeah, that's a very good
So-
point. Yeah, this is cool. Yeah, so yeah, great.
Did this all fall out because we said, hey, unit circle, the x is the cosine and the y is the sine?
Exactly,
And
that's
then-
where we started, right? I mean, all those come about. All these came about from that unit circle, and the x-axis is, or sorry, the x coordinate is cosine and y coordinate is sine.
Nice.
Right?